So hi, my name's Jack. This is Brandon. This is our talk. We had a photo of some guy here. Didn't know who he was, so we replaced it with a more familiar face. So who are we? This is Brandon. I can let him speak to himself. My name's Jack. We work with a team called Emerging Threats, which was acquired by Proofpoint many years ago. We put out the Emerging Threats Pro and Open Rule sets. If you've ever had false positives or problems, it's probably because of us. So, don't hit us, or maybe buy us a beer if we've helped you out. Brandon, you want to speak to yourself?
I'm Brandon. I do the same thing that Jack does. Konstantin's going to join live later, I think. The only thing that I'll add is that if you do have false positives on a rule set, please submit it to us. Give us some feedback. We'll adjust rules as necessary.
Please. Cool. So this talk, why does this make sense, right? So we came up with this little acronym, configuration extraction to network traffic signatures, SENT. So the goal here was to basically enable analysts to automate simple signature creation from extracted malware configuration. So a lot of common malware families these days that communicate over the network contain configurations, and they tell you exactly where they're going to connect to, how they're going to do it, and so we want to kind of leverage that to save some time, basically, at the end of the day, just because the stuff that can be automated, the low-hanging fruit, the things we know about, push that to the side so we can focus on the more unknowns and bigger sort of fish to fry. So a lot of these families utilize things like SSL, TLS, so it's easy to extract like certificate information, domains. Some of them utilize things like RC4 keys that are hard-coded, so we can use that to basically create really efficient fast patterns on certain encrypted data. Something to keep in mind, though, this little disclaimer is, this will extract things like DNS, for various domains, things like that. I would highly recommend not just running like a million DNS rules. It's probably not a good idea. This is more of just kind of like, a fun proof of concept of something that we can do. It's really useful maybe in sandboxes, things like that, but unless you're, kind of a pro user and have like a really good, like a mature program for running your network detection, I would just be a little careful. So here's kind of an example of what I'm talking about when I say configuration extraction and creating these SIGs. So here we have an example of smoke loader where the configuration was extracted, and we have here like 6 domains. And so we can just really quickly create 6 DNS signatures looking for those specific domains. In addition to that, we also have an RC4 key, so if we wanted to kind of go further, we could maybe use that to write some more rules based on the actual traffic outbound. Here's another example. This is async-rat, so this is sort of what that configuration extraction looks like. And from here, we can actually see the certificate common name, so this WP fresh value. And so looking at the actual traffic from this infection, here we can see it, if we go down to the actual certificate that's sent to us, and we can just really quickly make a rule that, looks for that certificate information. And again, it's very trivial. It doesn't take much. It's not a very big brain kind of thing. But again, it's really solid detection because we know exactly what we're matching on, and it's basically given to us by the malware. So that's kind of what we want to automate and turn into usable stuff. So just to kind of extend as well, like more malware that does have extractable configurations, these are some pretty big names here, like Cobalt Strike, Ursnif, Zloader, just all these things that we see kind of day in, day out being delivered via email, various, mail spam stuff. And again, these all have configurations that we can leverage to write signatures on. When we talk about things like sandboxing technologies, most of the things that we utilize are based on Cuckoo Sandbox. So Cuckoo, is kind of the golden standard for sandboxing. Back in 2010 is when it was released, and it is really, really cool. It's very modular, and it allows companies like Hatchings, Triage, Cape Sandbox, and many others, both public and private, to detonate these malware samples and extract exactly what we need from it. So for this instance, or for this talk and this project, we decided to go with Cape Sandbox. the reason why it's a very nice public kind of open source sandboxing source. The developers are very, very committed to the project. They develop, various new features. They completely rewrote it to be compliant with Python 3 not too long ago, and I would say, it has a strong community behind it. So that's why we decided to go that way.
The other thing that I'd add there, is that Cape also has a small set of publicly available configuration extractors. Configuration extraction is kind of the gold mine of malware analysis, where you can fully automate it and then get the configs out at scale. And so a lot of people really hold those configuration extraction and the methodologies close to their chest, not only because it's a very quick way to do the job, but also if the actors get a hold of the fact that you are doing that, then they're just going to change the way that their configuration is, and then it's a cat and mouse game. And so it's kind of cool that Cape has that availability public, which is another good reason why we chose it. Do you want me to keep going? All right. All right, so this is Cape. This is kind of what it looks like. This is a publicly available instance of Cape. It's CapeSandbox.com, I'm pretty sure. They are super security researcher friendly. So they have an API that you can more or less create your own API for. There is some registration required, but very security researcher friendly. And then down below you can see those detections there. Not all of them have configuration extractions, but some of them do. So it's kind of cool. So there are some, so when we start talking about how we got this to work, there are some prerequisites kind of for Cape to be set up in order to get the automated signatures. So a functioning Cape instance is obviously required. It's relatively easy at this point. The maintainers have created a set of 2 scripts, more or less, that if you're okay with accepting a lot of the defaults and don't want to do a lot of customizations, that you can kind of do that. There are, within Cape, there are some configuration extractors that need to be enabled. So they support 4 different frameworks, I guess: MWCP, rat decoders, malduck, and then Cape has their own as well. So that's all within the processing.conf file that you can edit. And then working Suricata, so Cape will actually use Suricata socket methodology and submit the PCAP from the run over to Suricata and then have that processed, which gives us a lot of the TLS artifacts that we'll use. So it's important to have Suricata working. Again, the scripts will actually do that for you. Install Suricata update, pull down the latest open rule set, etc. And then Sense is our reporting module. So the way that we implemented our code was a reporting module. And so you just got, by default, it's turned off, and so you just got to go turn that thing on, and then everything will start working. Do you want to do this?
Oh, no.
Okay. Okay. So then there are some, not everything works. Oh, thanks. Thanks, boss. Not everything works every time. And so this is a good example of a problem that we had where we were running squirrel waffle. We were getting good detection of it, but we were not getting the configuration extraction. So, it's kind of a finicky thing. There's a lot of moving parts that need to come into play in order to keep that going. You've got decoy domains, which is another issue. A lot of malware families will have them now, so they'll put in, like Intel and Apple.com and major websites. So if we start sigging up those, we're going to have a bad day. So yeah, it's just kind of something to keep in mind that there are issues with this. I think automation is great until you kind of shoot yourself in the foot with it. So be careful. This is another issue that we ran into. We wanted to support Remcos for its automated configuration extraction. It's a pretty well-known commodity rat. And so what I found was that I'd write it, and then I'd write, kind of the logic to deal with this, and it wouldn't work. And so it turns out that there were actually 2 different configuration extractions occurring, and I had them both enabled. And so we actually had to kind of code our way around that and deal with both of those. And so on the left there, you can see MWCP from the Defense Cyber Crime Center. And then on the right, rat decoders from Kev the Hermit. Both of those are like they're both frameworks to do the configuration extraction, because Sense supports both of them. Then when we write our rules, we have to be able to support the way that they store those configurations. So it's kind of interesting problems. I'll let you go.
Cool. Yeah, so right now we're supporting a few malware families that we've actually built out all the support for, in the sense that rules will actually get created based on the extracted configs from Cape. So the first one is Squirrel Waffle, which if you're curious where that name came from, the person who created that name is in the room today with us. I won't out them, but I will make note that they're here. So if you have any questions where that came from, you can go straight to the source. But yeah, Squirrel Waffle is a loader. So typically it's dropped by malicious documents or JavaScript. So it'll basically communicate via HTTP. So what it'll do is send base64 encoded XORed victim data in a post body. And down here you can see the traffic and the config that was extracted. We actually have part of the URI path that is hard-coded in that config for the sample. So we can actually, have a very, very solid sort of fast pattern on that rule due to the fact that all of that is hard-coded there. Because the victim data will change, so we can't necessarily utilize that, but because that URI is hard-coded, we can rely on that. So here's kind of an example of what that post looks like. So, just picking out one of the streams in the traffic, we can see, the URI and the host line up to what was extracted in the config. And then if we click that download sense rules, we can see our HTTP-based rule here. That's just looking at the command and control activity. And in our request line, we're just looking for that post to that, basically that starting directory, as well as the HTTP host of the domain that was configured with it. And Sense will also do DNS signatures based on these as well. So just in case, for whatever reason the host is down, something like that, we can still see that DNS query going outbound and hopefully alert to some malicious activity. So from that one sample, we were able to generate 36 rules, 18 HTTP, and then 18 DNS. So here's an example of what that rules file looks like when it's downloaded from Sense. Very cool, some metadata that exists that's not in this screenshot just for readability, but it'll include like a link to the run in Cape, a reference MD5 hash, and a created with date. And then, of course, the logic is in there to increment the SIDs. So, you could basically run this as is and it would be a working rule set. So it's kind of a neat little example there. So we kind of created 36 rules out of nowhere, and it took zero effort because it was completely automated for us. So saved a lot of time. I don't know how long it would take anyone in here to write that many rules, but probably too long and not worth it. So here's another example of one that we're supporting, TrickBot. So this is kind of a multifaceted malware. It's evolved over time. It's been around forever. It's a banker. It's a loader. It's a, this, that, the other. This one primarily communicates via TLS. So we actually had, sort of an interesting problem to solve here. So as you can see in the configuration below, we have a list of IP addresses and the ports in which it is expected to communicate with, right? 443. So no problem, but if we're actually looking at the traffic, we can see the certificate, common name there, and that doesn't appear in our actual config. So to kind of come around that, we're able to, extract the IPs from the config, but then tie that to the Suricata log that is created within Cape to then actually extract the network information that is parsed to then build our rule. So kind of a cool little, way to get the actual certificate that's being used behind these command and control servers and the IP addresses. So if they change, we're able to basically get what's getting returned to us in real time from that run. And then, of course, we just smash that data into a rule that kind of is painful to look at, but of note, we're able to convert some of those special characters into hex, so it'll actually run and not bomb out Suricata. But yeah, I thought that was a pretty neat example there. And then just another one that we support here is Remcos Rat. So Remcos is a backdoor, remote access Trojan. We're able to extract configurations from samples, any version that's under 3.0. So this one communicates via raw TCP. So it just creates a session back to the command and control server, and it uses a hard-coded RC4 key to encrypt the data that's going back to the command and control server. So in this output here, you can see the version, which is 1.7, and then you can see the command and control server, and that Nathan Nagauchi 2509, that's the password that is used for the RC4 encryption. So of note, with Remcos RAT and inside of the sort of sense configuration, we account for Remcos in 3 different ways. So we're able to extract the IP addresses. So in this case, this is an internal IP. So we wouldn't want to write a rule that is detecting that IP address. So because it's not routable, we're going to not include that rule. And instead, we're going to go look at the domain. Is there a domain that we can write a DNS rule for? No, there isn't, because, again, it was just an IP address. So last but not least, we will then create a rule based on the password that was extracted from that sample. So that's what we went and did here. So basically what Remcos, the packets start with this data start and then 4 null bytes. And so we take that extracted password, which is that Nathan Gauchi 2509, and we use that to RC4 encrypt the data start null byte string. And so that BF, CD, 35, etc. is then what goes into our rule. And in this case, we did in the message indicate this is the passphrase. So, if you're doing any sort of, parsing of the messages or things like that, you can actually see, exactly which password was used. And again, this is a very high fidelity signature because it's, incredibly specific to this sample. And because this changes per sample, this is why the scale of Cape and being able to send, 500 samples at it and get, 250 rules back, depending on how much overlap there is really powerful. Because again, it would take a ton of time to go through every single sample and basically hand create these. Cool. So future considerations. So basically support more malware config parsing. Like we, obviously showed that huge list of all the different families that have configurations we can extract and use SIGs on. It just requires the work. So it'd be really cool to just basically keep this going with more malware families, different styles of signatures. Part of that would be different types of rules. So, basically expanding the types of rules that we're able to create, similar to how we did with Remcos, but just extend that capability across other families. Data sets. So data sets are really cool. Maybe, taking all those like domains or IP addresses and shoving them into a data set, and then calling some data set rules is a more efficient way or a better way to handle this much stuff. Or IP rep firewall block lists. Like maybe SuriCon is not the right tool for the job when it comes to things like DNS or IP addresses, and maybe you can export some of that config stuff to directly to a firewall or something like that. But yeah. So we're going to go ahead and cut over now, I have no idea how, to Konstantin, who is not with us. He's our German counterpart, and he is gracious enough to kind of run us through a demo, look at some code, look at some sort of live examples of how this stuff works. Wow, that's great.
Hi, I'm happy to be live. So welcome to the demo. I will just share my screen and start it. Hello everyone to the demo of Sense. I have 3 agenda topics. At first I will start with introducing you into Cape v2 and show you where to find it, how to use it, and how to contribute to the project. Afterwards, we will go more into details about Sense, which is a reporting model of Cape v2. I will also show you where to find it, how to use it, and how to contribute. And I will show you the 3 examples that Jack and Brandon just explained to you: the Squirrel Waffle Trickbot and Remcos malware runs. Last but not least, if you're running Cape v2 and also want to try out Sense, then we would be really happy if you are able to contribute your generated signatures to the ET Open rule set. So I will explain how you can reach out to us. Starting with Cape v2. Cape v2 is a public open source sandbox. It's a fork of Cuckoo written in Python 3. It's this repository on GitHub under Kevin O'Reilly, Cape v2. Everyone can find it. I also put in the link on the slides. And basically you have all descriptions you need in the README. So you have a link to the documentation. which looks like this, and it's very detailed. Everyone can easily set up our own sandbox instance and get it running. This repository is the main repository of the sandbox. There are two other repositories which are called Cape Mon, which is responsible for the hooks of the Windows API calls. And there is another repository called Community that contains all the signatures of the sandbox. For example, you have Jara signatures. In this case, this is a Dridex signature under the data Jara Cape directory. But as you can see, there are a lot of more Jara signatures in there. There are also Python signatures, which are matching on the behavior of the sample in the sandbox run, and they are also in the community repository under modules signatures. So we can look into two Ramcos signatures that are written in Python. For example, the Ramcos mutex signature and the Ramcos rec keys signatures are firing on Ramcos specific mutexes and registry keys observed in a sandbox run. As you can see, it's a simple regex to match on that indicators. So going back to our main repository, the Cape v2 repository, you have two other important subdirectories, which is the processing subdirectory. For example, you have the Suricata processing module, which is responsible to match the PCAP that has been generated during a sandbox run against Suricata and a given rule set after the sandbox run has ended. So all the processing modules are running after a sandbox run has ended. There are also a lot of reporting modules. For example, our Sense module is a reporting module, but you also have, for example, a report PDF reporting module that creates a PDF report, or you have a MISP reporting module that pushes the sandbox results to a MISP instance. So those are, of course, also running after the sandbox run has finished. Going back to our main repository, in the README, you can see that there is a free community instance available online, which everyone can use. So going to this link will lead us to this free sandbox instance of Cape v2 that everyone can use. So you can see there are around 300 samples per day and more than 170,000 samples in total. And there are a lot of different malware families detected in this instance. So this is a good starting point for researching different malware families and extracting configurations. So we can look into Ramcos. We just click on this link, and then we will get all samples that have been detected as Ramcos. And you can see there are a lot of them. If we look into one run, I would like to give you a feeling how a sandbox run looks like. So you have this quick overview page that displays you the config if there is a config, and also all the basic file details like the hash or the PE timestamp or the file type. And if we scroll down, we have all the signatures that are firing in this run. If you remember a few minutes ago, I've shown you the Ramcos mutex and Ramcos registry key Python signatures, and you can see those are firing in this run. Also, a Jara rule is firing. That's why Cape detected the Ramcos malware family, and then it was also able to extract the configuration, as we can see here. You have a lot of other useful information in such a sandbox run. For example, you have for PE files a lot of static information. You have the behavior tab where you see the whole process tree, and you can see every single Windows API call that has a hook with all the parameters. So that's pretty useful if you want to build up a Python signature and create a state machine of Windows API calls that happens one after another. And which is interesting for us is also the network analysis, because you have all the Suricata stuff in there. So in this case, we will see that there are actually ET signatures firing that indicate that this is a Ramco sample. And also we do not only have alerts, we also have like all the TLS information available here and also the whole HTTP metadata. So this is pretty useful because you have everything at one place. Also, if we go back to the quick overview, we will find the ET signatures in this signature tab here as well. So that's pretty cool. Of course, there is a lot of more information in the sandbox run, but I think that's enough for a quick overview. Continuing with my second agenda topic today, which will introduce you into SANS. I will run this sample in our own instance of Cape, which we used for testing for this project. So this sample should be TrickBot, and I just leave it with the default settings and run it. So a new analysis has been started, as you can see here, and this will take up to 4 minutes until it's done. So we will come back later to this run. I've told you already that SANS is a reporting module in Cape v2, so we were able to open source it, and it's already merged, so you can find it if you look into the Cape v2 repository, and you will find this SANS reporting module. It's pretty easy to understand because it just takes the config from a dictionary, from the results of the sandbox run, and then it looks if it detects a known malware family that we have a SANS module for. So for example, for Ramcos, it runs the Ramcos function. For SquirrelWaffle, it runs the SquirrelWaffle function. And for TrickBot, it runs the TrickBot function. The functions are stored below the libcuckoo common SANS subdirectory. So you can see all 3 currently supported malware families in there. And if we look into one, let's pick SquirrelWaffle, we will see that this is actually the part where the rules are getting created. So it just uses the C2 parse and the C2 host name that was retrieved from the extracted malware configuration and puts it into the string, which will then be our Suricata signature. So it's not magic. If you're starting using it, please be aware that you have to enable the reporting module because it's disabled by default, and you can do that in the kp2 conf reporting configuration file. Looking into our first example, which is again SquirrelWaffle, you can see that we have the config in there, and then you have this button where you can download the SANS rule set. And if we go to my shell, we will have the rules in this file. And you can see that there have been 36 rules created, and all of them are containing the information that we have retrieved from the malware configuration. So that's pretty cool. What we also can do now is to rerun the pcap from the sandbox run, which we are able to download from the network analysis tab over here. We can rerun that pcap against our newly created sense rule set. And then if we look into the logs, we will find alerts in there. So it's actually working. Moving back to our sample, we can look into a RAMCOS sample too. So as Brandon and Jack just explained to you, there are two different types of RAMCOS configurations. One are looking like this and the others are looking like that. But we don't care because we can create signatures for both of them, because we know that there is a known plaintext in the C2 communication of a RAMCOS beacon, which translates to this data start. And by encrypting this known plaintext with the password that has been extracted from the configuration, we can come to our ciphertext that will be viewable over wire, so we can create a signature for that. Going back to my shell, we can also look how this looks like for those two samples. So for the first one, we only have this TCP signature that has been created out of the passphrase as a password for the RC4 decryption, and then it encrypted the known ciphertext. And for the second one, we also have an additional DNS signature, because in this case, there was a C2 host name, and in the first case, there was a C2 IP address. Okay, moving back to our TrickBot sample that still hasn't finished yet. So we will have to wait a bit. Now it's done. So we have the detections here. It is detected as TrickBot, and you can see we also have the malware configuration. Over here we have the version, and we have the G tag, and we have all the C2 servers available here. So we can also look into the network analysis, and we will see that we have also already a lot of Suricata alerts, and we have TLS information available here. So we can not only use the extracted configuration for creating our signatures, but we can also use the things we observed in the sandbox run. For example, the extracted TLS metadata from Suricata, which we do in this case. So we can again download our sense rule set, and then we can look into the created signatures. And we will see that exactly those values have been used for our signature, combined with the configuration, G tag, and version. So both information are combined in this case, which is pretty useful. Also, you can see that we always put the MD5 of the sample in the metadata. We put the reference to the sandbox link in there, and we of course put the date of the sandbox run in there, and we increment our signature IDs, and you can set the starting signature ID in the reporting configuration, in the reporting module configuration. So yeah, that's it. I hope you will try it out. And if you try it out, we would be really happy if you can contribute your rules to the ET Open rule set. So this is how you can reach out to us. We have this feedback module where you can report also false positives to us. We have, of course, the mailing list, which most of you probably know. And we have Twitter. So please reach out to us. We would be happy if you try it out. And yeah, looking forward to your questions. So thank you for your attention. I'm going back to stage to Jack and Brian.
All right. Ready for questions?
Sure. Yeah,
okay.
sure.
Questions in the room?
Sweet.
How about online?
People are typing.
Okay. A question in the back here?